Okay, this video is going to take you through the solutions of the midterm review packet. So for number 1, it says to find the midpoint and the distance. For midpoint, we add the two x's. So 2 plus negative 3 over 2, and then we subtract, and then we add the two y's. 3 plus negative 6 over 2. I get negative 1 over 2 and negative 3 over 2. And that's the midpoint. For the distance, we do the square root of x2. So we can make this one x1, y1, and x2, y2. Negative 3 minus 2 squared plus negative 6 minus 3 squared. Square root of negative 5 squared plus negative 9 squared. Square root of 25 plus 81, square root of 106. I would see if that breaks down. So 2 and 53, which doesn't break down any further, which means the square root of 106 stays as the solution for the distance. The second one is graphing an equation. I'm sorry, graphing, well, it is an equation, but this is a line. We start at the y-intercept, which is negative 4, and then we use the slope, which would be 5 over 1. We go up 1, 2, 3, 4, 5, and over 1. And you can reverse that too if there's not the right amount of space. And then we just connect those points with a line. For number 3, we're looking for the domain of the function. When there's a denominator that has a variable, we set that not equal to 0. So to solve this, we're going to factor it x minus 3, x plus 2. And neither of these can equal 0. So x cannot equal 3, and x cannot equal negative 2. In interval notation, that's negative infinity to negative 2. And then negative 2 to 3, and then 3 to positive infinity. Number 4 says that you're trying to find f times g. So I would do 6x plus 4 times 5x plus 9, and then FOIL that out. So I'd get 30x squared plus 54x plus 20x plus 36, and I get 30x squared plus 74x plus 36. For 5, which has the multiple parts, the first one you're adding the two functions. So it says to find f plus g. I would do x squared plus 2x plus 5 plus x squared plus 2x plus 4. So I get 2x squared plus 4x plus 9. For f minus g, it's pretty similar, except we are going to leave the signs of the first one. And then when we subtract, that negative is going to go to each one of these. So it would be minus x squared minus 2x minus 4. These cancel, and then 5 minus 4 is just 1. F times g, this time we got to FOIL this out. So I'm actually going to do this off to the side. I would get x squared plus 2x plus 5 times x squared plus 2x plus 4. So I've got to do first x squared times x squared, which is x to the 4th. First, second there is 2x to the 3rd, 4x squared, and then 2x times each one of these, so 2x to the 3rd, 4x squared, 8x, and then the last 5 times each one of these, 5x squared, 10x, and positive 20. There's 1x to the 4th. There are 2x to the 3rd, so that's 4x to the 3rd. There's an 4x squared plus 4x squared is the 8x squared plus 5x squared, so 13x squared. Ax plus 10x is 18x plus 20. For d, it's f over g. So this time the x squared plus 2x plus 5 goes over x squared plus 2x plus 4. Now, if this was factorable, I would try to factor it to see if something could cancel out, but it's not, so it's going to stay the way it is. For e, it says f of g of x. So we're going to take g of x and plug it into the f. So everywhere there's an x goes this whole expression. So I'd get x squared plus 2x plus 4 squared plus 2 times x squared plus 2x plus 4 plus 5. So I'm going to square this, expand, and FOIL. And I'm going to do that off to the side. So x squared plus 2x plus 4, and x squared plus 2x plus 4 is x to the fourth plus 2x to the third plus 4x squared plus 2x to the third plus 4x squared plus 8x plus 4x squared plus 8x plus 16. X to the fourth plus 4x to the third plus 4 plus 4 plus 4, 12x squared plus 8x plus 8x, 16x plus 16. So that's the squared part. And then we would distribute this here. And then the plus 5. And now we just combine like terms. So x to the fourth. There's only one. 4x to the third. 2 plus 12, 14x squared. 16 plus 4, 20x. And then 16 plus 13, 29. For f, it's f of g, but this time it's f of g of negative 4. So we're going to take that negative 4, we're going to plug it into g. So negative 4 squared plus 2 times negative 4 plus 4 is 16 minus 8 plus 4. 8 plus 4, which is 12. And then you want to find f of 12. So I'm going to take the f, which is the x squared plus 2x plus 5, and plug in 12. 12 squared plus 2 times 12 plus 5. So I'd get 144. Plus 24 plus 5. 168 plus 5, which is 173. That's that one. Okay, 6, find the inverse of the function. So to find the inverse, we start by replacing the f of x with a y. Then swap the x and the y. And then solve for that new y. So I'm going to multiply both sides by 5. 5x equals 2y minus 1. Add the 1. 5x plus 1 equals 2y. And divide by 2. And then that y becomes f negative 1 of x. 5x plus 1 over 2, which could also be written as 5 halves x plus 1 half. For 7, you're trying to find the center and the radius. So you want to do the opposite of what follows x. 6, opposite of follows y, negative 3. And then the square root of the number by itself, which means the radius is 8. For number 8, we're going to distribute the negative in here. So 6 plus 7 minus 4i, distribute negative here, plus 1 plus 6i, and then combine all our like terms. A plus bi means the i's come last. So 6 plus 7 is 13, plus 1 is 14, and then negative 4 and positive 6 would be positive 2i. For number 9, we're going to FOIL this out. So 6 times 4, negative 6 times 4 is negative 24, negative 6 times I, negative 9i times 4 is negative 36i, and then negative 9i times I is negative 9i squared. We can combine these, so 42i, I squared becomes negative 1, and this becomes positive 9. So this is negative 15 minus 42i. All right, number 10, divide and express the result in standard form. We have to multiply both the top and then bottom by the conjugate. So 4 plus 3i. In the numerator, I FOIL it out, 28 plus 21i plus 32i plus 24i squared. 28 plus 53i, this becomes negative 1, so minus 24. And I get 4 plus 53i as my numerator. The denominator, because we're multiplying by a conjugate, we can actually use the shortcut a squared plus b squared. We ignore the I, just take the 3, and I'd get 16 plus 9, which is 25. Number 11 says to determine whether the quadratic function has a minimum value or maximum, and then find the coordinates of it. So because this is a positive x squared, this has opens upward and it has a minimum value. So to find the minimum, we need the vertex. So negative b over 2a. B is negative 2. So this becomes negative negative 2, or 2 over 2 times 1, which is 2 over 2, which is 1. So that's the x coordinate of it. And then we have to take and plug it back in for the x values. 1 squared minus 2 times 1 minus 6. 1 minus 2 minus 6, which is negative 7. Number 12 says, find the leading coefficient test to determine the end behavior. So you want to look at the one with the highest exponent, which is here. It's odd, which means one's going to go up, one's going to go down. And then because it's negative, I know it rises left and falls right. 13 says to find the zeros of the polynomial. This is factorable by grouping because there's 4 terms. So we set this equal to 0. That's how we find the zeros. I'm going to take out the x squared. Take out a negative 1. And I get x plus 4, x squared minus 1 gets factored further, x plus 4, x plus 1, and x minus 1. So then we set each of them equal to 0. And I get negative 4, negative 1, and positive 1 as my zeros. 14, find the zeros of the polynomial and then give the multiplicity for each zero, tell whether it touches and turns around or crosses through. So the first thing I'm going to do is set each of these equal to 0. And if I had 0 equals 2x squared, I'd divide by 2. I'd still have x squared equals 0. I'd square root both sides, but it'd be a plus and minus square root 0, which means it's 0, but there are 2 of them. That's my multiplicity. Then I get x squared would equal 5. X would equal plus and minus the square root of 5. Each of those multiplicities would be 1. And then I get x equals 9. So at plus and, well, let's separate it out. At negative root 5, it's going to cross through. Positive root 5, it's going to cross through. At 9, it's going to cross through. But at 0, it's going to touch and turn around. So even amount bounces or touches and turns around. Odd amount crosses through. 15 says to divide using long division. So I'm going to put the negative 3x minus 2 on the outside. 9x squared minus 15x and minus 14 because there's nothing missing and it's already in decreasing degree order. Then I divide first into first. So I'd have to multiply by negative 3. Gets multiplied by the negative 3, positive 9x squared, and the negative 2 becomes positive 6x. We change our signs. These cancel. Negative 21x, bring down the negative 14. First into first again. This would be a positive 7. Multiply it out. Negative 21x minus 14. Change your signs. And they both cancel, so the remainder is 0. So the answer for this is negative 3x plus 7 with a remainder of 0. 16 says to divide using synthetic. So on the outside goes the opposite of what follows x. It's a positive 2. This is missing the x to the 4th term and the x squared and the x term. So they're all going to get zeros. So I'd start with 1 for the x to the 5th, 0 for the x to the 4th, 1 for the x to the 3rd, 0 for the x to the 2nd, 0 for the x, and then 4. Bring down the 1, multiply by 2, put it in the next column, add it, multiply by 2, put it in the next column, add it, multiply by 2, put it in the, add it, put it in the next, multiply and put it in the next column, add it, multiply it, put it in the next column, and add it. This is my remainder. This gets the x squared, the x to the 3rd, and the x to the 4th. So it would be positive x to the 4th plus 2x to the 3rd plus 5x squared plus 10x plus 20 plus the remainder, which is 44, over the divisor, which is x minus 2. All right, 17 says to solve the equation given that 5 is a 0 of it. So I'm going to take 5 and put it on the outside of the synthetic division bar. That's 3, negative 34, 81, 70. Nothing's missing and it's already in decreasing degree order. Bring down the 3. 15, subtract that. Multiply it out. add it, multiply it out, add it. You should get 0. If you don't, you did something wrong there. This gets the x and this gets the x squared. So now I would want to factor this if I can. So I'd be looking for factors of 3 times negative 14, which is negative 42, which sum to negative 19. So 42 is negative 21 and 2. That gives me that negative 19. Replace the middle term with them. And then factor by grouping. Take out a 3x. Take out a positive 2. X minus 7 and 3x plus 2. So because it says to solve, it wants all the zeros. It wants the 5 that came from what was given and outside the square of the synthetic division. And then I would set these equal to 0. And I'd get x equals 7 and 3x equals negative 2 and x equals negative 2/3. All right, for 18, it says vertical asymptote. So for this, we set our denominator equal to 0. This factors to x minus 4 and x plus 2. So each of them equals 0. X would equal 4 and x would equal negative 2. And those would be our vertical asymptotes. They're asymptotes, so they're lines. They get the x minus as part of the answer. For 19, we look at the exponents in the top and the bottom, the highest, and they are the same. So this is one of the leading coefficient cases. It would be y equals the leading coefficient of the top, which is the number on that front there, which is 4, and over the leading coefficient, the bottom, which is 2. So y equals 2. Again, you need the y equals because it's an equation, is a line. So you need the equation. Okay, 20 is one of your open-ended ones, so this is your graphing one. So I would make a t-chart because it's exponential. Negative 1, 0, 1. Plug in my points, so 1/3 to the negative 1, 1/3 to the 0, and 1/3 to the first. This is 3, 1, and 1/3. Negative 1 and 3, 0 and 1, 1 and 1/3. There's a horizontal asymptote right there at 0. So my curve does that. For 21, also open-ended, this is the graph of the log. So if I'm graphing this, I'm going to change f of x to y. I'm going to convert this into exponential, so the 5 picks up the y. And then we add the 1. And then we plug in for y for the logs. So I'd get 5 to the negative 1 plus 1, 5 to the 0 plus 1, and 5 to the first plus 1. 1/5 plus 1 is 1 and 1/5. 1 plus 1 is 2, and 5 plus 1 is 6. And the vertical asymptote this time is at x equals 1. I know that because of the horizontal shift. So this gets my line and my graph. Now comes the log. So 22 says to evaluate the expression without using the calculator. So 3 to what power gives me 1/9? It would have to be 3 to the negative 2 because it would have to be a negative exponent to bring it to the bottom and then square it. So negative 2 is that answer. 23, ln of e cancels, and I get just what's left of it, which would be 16x. 24, 25, 26, 27 says use the properties to expand or condense, because some of these are condensing. So for 24, I would expand. When I expand a product, it becomes addition. So this is log base 2 of 4 plus log base 2 of x. And then you can raise 2 to a power to get 4, so that actually gets simplified as 2 plus log base 2 of x. For 25, this is subtraction, so it becomes division. Ln of e to the 6th minus ln of 11. Now the 6 can either bump to the front here, or you could cross it out and keep the 6th. Either way, you end up with 6 minus 11, of ln of 11. 26, I've got a product and a quotient, so a log w of 11 plus log w of x minus log w of 2. And that one can't be reduced, so it stays that way. This time we're condensing, so the numbers in the front become the exponent. This would be log ln of a to the 8th minus, this becomes the exponent, ln of b to the 5th. And then because it's a minus, it becomes division. Ln of a to the 8th over b to the 5th. '28 says solve the equation by expressing each side as a power of the same base and then equating the exponents. So 3 is the base we want to get. 27 can go to the top, making it 27 to the -1, and then 27 is 3 to the 3rd. So this would become 3 to the 6 minus 3x equals 3 to the -3rd. Once the bases are the same, the exponents get set equal to each other. So 6 minus 3x equals -3. Subtract the 6. Divide by -3, and x is 3. 29 and 30 are solving log equations. For 29, you've got 2 logs on one side, so we're going to condense first. Log base 4 of x plus 5 times x minus 1 equals 2. I have 1 log on one side, so I'm going to convert this to exponential. The 4 comes over and picks up the 2, and we FOIL this out. X squared, it would end up being x squared plus 4x minus 5. 16 equals x squared plus 4x minus 5. Move the 16 on the side with the 5. Factors of -21 that sum to +4 would be x plus 7, x minus 3. Set them each equal to 0. X equals -7 and x equals 3. Now, because there's a log in my original equation, I have to check these. So if I plug -7 in here, this ends up as -2, and I'm trying to find log of -2. Doesn't work, so I cancel the 1 out. 3 plus 5 is 8, that's okay, and 3 minus 1 is 2, and that's okay. So I get to keep the 3, but I had to eliminate the -7. For 30, there's 1 log on either side of the equal sign, so I use the 1-to-1 property, which just says ignore that log and set these equal to each other. Subtract the x, add the 2, divide by 3, and x equals 2. Make sure I can plug this in. 2 here makes this 6, which is fine. 2 here makes this 6 minus 2, which is 4, which is fine. '31 says the given angles in standard position determine the quadrant which the angle lies. So -105 is going to go around past the 90 mark, but before the 180, which puts this in quadrant 3. 32 says find a positive angle less than 360 degrees that is coterminal with the given angle. So coterminal means add and subtract 2 pi. If I subtract 2 pi here, I end up with 13 pi over 6 minus 12 pi over 6. Which is pi over 6, and that is less than 360, so that's my answer. Find the point P is on the unit circle, corresponds to a real number, find the function. So I want to find secant, which is the reciprocal of cosine. Cosine is x, so I take the x, I flip it, and then I have to rationalize it. So square root of 33, and I get 7 square root 33 over 33. 34, you find the cosecant of 7 pi over 2. This would be 3 1/2 pi. Remember, evens is on the right, odds is on the left. So if 3 would be here, and then 1/2 means it's at the bottom here where it's 0, -1. The cosecant is the reciprocal of sine. Sine is -1, flip -1, and it's still -1. 35 says use reference angles to find the exact value of the expression. So because this is an over 3, I know my reference angle is pi over 3, and the coordinate point there would be 1/2 and root 3 over 2. It's sine, so I know it's root 3 over 2, but then I got to locate -2 pi over 3, which is left, because that's, I go clockwise because it's negative. Past the halfway point puts me in quarter 3, and because all students take calculus, I know that is a negative square root 3 over 2. These are your inverse functions. So remember, for sine and tangent, we use from negative pi over 2 to positive pi over 2. And then for cosine, we use 0 to pi. So sine of root 2 over 2 happens at pi over 4. Cosine of negative root 3 over 2 happens at 5 pi over 6. And tangent of negative root 3 happens at negative pi over 3. 39 says to find the point that's on the terminal side. So 18, positive 24 means I went to the right and up. So I need to find this, I need to find the hypotenuse. So 18 squared is 324. 24 squared is 576. Add those together and you get 900. Square root of 900 is 30. So that's your missing side. Cosine is adjacent over hypotenuse, 18 over 30, which reduces to 9 over 15. And again, 3 over 5. 40 says to use a sketch to find the exact value of the expression. So I'm going to use my triangle, put theta in the corner. Tangent being 2 nines is opposite over adjacent. And I need to find cosine, so I need that missing side again. So 2 squared plus 9 squared equals c squared. 4 plus 81, 85. C equals the square root of 85, which would be 5. And 17 doesn't go any further, so this goes as the square root of 85. Cosine would be 9 over root 85. And then we rationalize. And I get 9 root 85 over 85. Okay, 41 and 42 are from your sum and difference. So sine of 75 would be sine of 30 plus 45, or 45 plus 30, it doesn't matter, which is sine 30 cosine 45 plus cosine 30 sine 45. At 30, my coordinate point is root 3 over 2 and 1/2. And at 45, it's root 2 over 2. So it's 1/2 root 2 over 2 plus root 3 over 2. And then the sine at 45, which is root 2 over 2. And I end up with root 2 plus root 6 over 4. 45, your goal is to figure out the pattern here. Obviously, this is tangent, and tangent, we match the sign in the top. So it'd be 5 plus 25, and the tangent of 30 degrees is root 3 over 3. Okay, now comes our transformations. So for 43, this is a squared, so I know it's a parabola. This goes upside down. This is left 2. This is down 6. Left 2, down 6, and upside down makes my parabola look like that. 44, negative is upside down again. The 2 this time on a square root, which is going to look like this. The 2 makes it tall or vertically stretched. The 2 inside is left 2. The 2 on the outside is up 2. So left 2, up 2, upside down and tall means it's going to look like this. So you can write tall, you can write vertically stretched, but you want to make sure you identify that it's being stretched. 45, now I've got a cubic function, so my shape looks like this. This goes right 3, this is down 2, right 3, down 2, and my graph points up, right, and down, left. All right, now I've got my trig functions. So this is cosecant, which means I'm going to graph 2 sine pi over x. My a is 2, which is my amplitude. My b is pi. The period is 2 pi over b, which is 2. I do 2 times a fourth times a half times 3/4. The first one is 0. The last one's the period. So this is 1/2, 1, 3/2, and then again 2. There's no phase shift because there's no parentheses with addition. And there's no vertical shift. So I just go to 0. This is sine, so I go 0, 0. I would go, you can actually cross these out, make this 1/2, 1, 3/2, and 2. So I'd go up to my amplitude, which is 2, back down to 0, down to -2, and back up. Now, because it's cosecant, I need asymptotes here, here, here. I need one more. So you can either continue it on this side or you can continue it this side. It doesn't matter. And then your parabolas are going to bounce off of those curves. So you need 4 asymptotes, 3 curves. There's one more than you need here just because I went to the right and to the left. You don't need to do both. 47, tangent. So negative 2 tangent x plus pi. This tells me it's going to be upside down. So it's actually going to point up left and down right, almost like a cotangent curve. The 2 means my a and my quarter points are going to be at 2. And then I'm going to take x plus pi, set it equal to negative pi over 2 and positive pi over 2. I'm going to subtract the pi, which is 2 pi over 2, and I get x equals negative 3 pi over 2. Subtract the pi, 2 pi over 2, and I get x equals negative pi over 2. To the one on the left, I'm going to subtract the period, which is pi over b. B is 1, so period is just pi. Subtract the period, and to the one on the right, I'm going to add the period. 2 pi over 2, so this is negative 5 pi over 2. And then this is, sorry, this should be negative pi over 2 plus 2 pi over 2. So I'd get pi over 2. And then those are your asymptotes. I go to, again, I can mark these in between negative 3 pi over 2, negative pi over 2, negative 5 pi over 2 would be over here, and positive pi over 2 would be here. Those are the asymptotes. The x-intercepts are in between there, so they'd be at 0, negative pi, 2 pi, negative 2 pi. And then you want to eyeball 1/4 and 3/4 and go up to 2 on the left, down to 2 on the right, up to 2 on the left, down to 2, up 2, down 2. And there's your negative tangent curve. Okay, for 48, this says identify or complete the identity. So it's sine x plus cosine x squared over 1 plus 2 sine cosine. So this squared would be sine x plus cosine x times sine x plus cosine x. I'd get sine squared x plus sine cosine plus, I'm going to reverse the order so it's the same, sine cosine plus cosine squared. Now these together are 1 plus 2 sine x cosine x over 1 plus 2 sine x cosine x, and there's just 1. (49), you can group sine plus cosine x. That's going to be 1 plus tangent squared, and 1 plus tangent squared is secant squared. For 50, you can distribute this in. Cosecant would be 1 over sine of x. So I can do that first. Distribute, I'd get 1 over sine x times sine of x plus 1 over sine of x times cosine of x. These cancel, and I get 1 plus cosine over sine is cotangent. And the last one is a duplicate of the first one. So we already know that answer. All right, we said skip 52 and 53 because those are double half angles. For 54, you're dealing with your interest. So because this is compounded quarterly, we're going to use the first one. 900 is RP. The rate would be 0.12. And then quarterly is 12 times a year. That's your N. 4 years that's your T. So it would be 900 times 1 plus 0.12 over the number of times a year, which is 12, raised to the N, which is 12, times T, which is 4. And then I can type that whole thing in the calculator. So 900, 1 plus 0.12 divided by 12 raised to the 12 times 4. And I get $1,451.003, so 0 cents. 55 says e to the 2x plus e to the x minus 6. So I'm going to factor this. This would be e to the x and e to the x, and then factors of negative 6 that sum to positive 1 would be negative 2 and positive 3. Split and solve here, and I end up with e to the x equals 2 and e to the x equals negative 3. We ln both sides of these and these, and I would get at ln of e to the x cancels, just giving me x, and ln of 2 is 0.69314. Here, I'd get x equals ln of negative 3, and that can't be done. So this is the only answer I keep. 56 says, from a boat on the river below a dam, the angle of elevation to the top of the dam. So I've got a boat on the river above a dam, or below the dam. This is 24 degrees and 8 minutes. If the dam is 2,039 feet above the level of the river, so this is 2,039, how far is the boat from the base of the dam? This is tangent because it's opposite adjacent. So tan of 24 degrees, 8 minutes equals 2,039 over x. Because the variable is on the bottom, I'm going to take this and divide it by that. So 2,039 divided by, make sure your mode's in degrees, tangent of 24, I can't read my own writing, 24 second apps go to the angle menu, and 8 second apps go to the angle menu again. And I get 4,551, let's say to round, 0.1, which means this is 4,551 feet. 57 says a building 290 feet. So you got a building and that height is 290. Cast 100-foot-long shadow. If a person stands at the end of the shadow, looks up at the top of the building, what's the angle from the person's eyes to the top of the building, and assume the person's eyes are 5 feet above the ground. So we need to take off this 5 feet from the 290. So then just the top of this would be 285. This is still 100, and I want theta. So tan of theta equals 285 over 100. And I would do tan negative 1 of 285 over 100, which is 70.66 or 70.7. Oh, it says nearest hundredth. So we're going to do 665. So it's 70.67 degrees. All right, the last two, save the easiest for last, are just the calculator. This, we're finding the tangent of negative 1.6. That is in radians because there's no degree symbol. So I just do tan, negative 1.6, and I get 32 point, says to round 4 decimal places, 34, sorry, not 32, 34.23252, or 253, so it stays this. And then here we're doing the inverse. So I would do sine negative 1 of negative 0.4, which is always in radians. So second sine negative 0.4, and I get negative 0.41151. So we keep it at 1. Oh, it says 2 decimal places. So it's negative 0.41. Make sure you read these instructions so you know what to round to. All right, that wraps up the review packet. Good luck on studying.